Good morning, everyone. This video on data structures using C language is brought to you by Newton's Group of Institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. And today, our topic is circular queues. So let us discuss the different operations what we are going to perform in circular queues. Can anyone say why they introduced the concept of circular queues? Here, the only disadvantage with the queues is whenever we delete one element from the front, all the remaining elements need to be shifted in the forward direction. So it is time consuming. For that reason, they have introduced the concept of circular queues. For suppose, consider the example. This is one queue. All the elements in the queue can be inserted from one end, which is called as an rear end. And from the front, we are going to delete the elements. Suppose that in this particular queue, if we have already some elements that are present, say 10, 20, 30, 40, and 50. For suppose we are deleting one element from the queue and we know that front will be always pointing to the first location with index value 0, which is nothing but the starting location. And front is always 0, which cannot be changed. Suppose we are being asked to delete an element, then we are supposed to delete the element from the front. Because deletion in the queues takes place only at the front. After deletion, we need to shift all the elements, which is nothing but 10 is replaced with 20, 20 replaced with 30, 30 replaced with 40, and 40 is replaced with 50. And then the rear will be moved towards the left by one position. This is what is generally happening in the queue. So after every deletion, for shifting these values, it consumes so much of time. So to avoid this problem, they introduced the concept of circular queues. So here, before going into the logic of the queues, let us see how we can create a queue. For creating a queue, what we need to do? So for creating a queue, first we need to define the queue variable, that is int queue of some capacity. That size, whatever the capacity we take, we can directly give it here in this square brackets, or we cannot give it by using another variable. That is wrong in according to the C or C++ syntax. Or else here the size, whatever we want to give, we can give it in the form of a macro. So here the macro we can define by using hash define capacity 5. So here 5 is the size, that is the value that of the capacity. And if you can see here, the capacity, we are writing it in capital letters. In general, the macro names are given in capital letters. Now we can pass this capacity value here. Why we are passing a macro as a size means because it is an preprocessor directive. That is, the value 5 will be placed in this place before the time of compilation itself. That is the advantage of creating a macro and passing in the variable queue. Here you can do one thing, you can write CQ because it is a circular queue. You please better write CQ. And besides that, we need to create two more variables because here the operations, whatever we perform on the queues, they happen through front and rear variables. So we have to define those variables also. So here my int rear is equal to -1, int front is equal to -1. So initial values of front and rear, we are taking them as -1, negative values. Why we are taking them as negative values? Because the queue is empty. So whenever the queue is empty, we take the int value, rare value and the front value as a -1 values. When they imply is -1, then the queue will be empty because initially we are starting creating a queue. So in a circular queue, the queue will be represented in the form of a circle. Here, there is no need to shift all the elements. That is the advantage of using circular queues over the general queues. Then, how the elements will be arranged, let us see. Here, it is the size of the circular queue is 5, index starting from 0 to 4. So here also, to perform the insert operation, we need to go with the rear, and deletion we need to go with the front. But in a circular queue, we can specify the front and the rear initial values with -1 values. So here, the front value will be equal to -1 and the rear value will be equal to -1. Means what? It means that when the front value is -1 and the rear value is -1, the queue is empty. So whenever the queue is empty, the front and rear values will be equal to -1. So when you try to insert the first element, then in a circular queue, front and rear must be equal to 0. So the front value becomes 0 and the rear value becomes 0. Now can we insert an element into the circular queue? So if at all, if we insert the element into the queue, how we are going to insert the element? According to the algorithm, insertion need to take place with the rear variable only. So here CQ of rear is equal to element. And after that, what we need to do? We need to increase the rear plus value. But here the rear plus value we are not going to use at that time. Before the next insertion only we need to do rear plus. Whereas in the queues we have done once after inserting the element, we have done rear plus. But here when the next item or the next element is getting inserted, then we go for rear plus. So if you insert with an element, say 10. So 10 will be placed there and it does nothing for the first time. So for the first time when you insert the element, that is when the front value and rear value are equal to -1, the front value and the rear value will become 0 and then the 10 value will be inserted into the queue. When you insert with the second element, suppose say 20, then we need to first increment the rear value. So the rear becomes rear plus 1, that is equal to 1. Then we need to insert the value 20 into this particular location. And when we insert the third element, say 30, then 30 will be placed at this particular location only after the incrementing of the rear value. So now my rear becomes 2. Then using this statement CQ of rear is equal to element, I will be placing with the 30. In the similar fashion, we can place 40 and in the same fashion we can place 50. So here the rear value will become 4 and 50 will be placed into the circular queue. So now when we insert the fifth element 50, you can see that the queue is full because the size is 5, the queue is full. If you can notice here, the condition here is when the size value is equal to rear plus 1 or rear is equal to size minus 1, the queue is full. So whenever the size value is equal to rear plus 1 or whenever the rear value is equal to size minus 1, we need to display the message saying that the queue is full. So here two things what we need to understand is when the front value is equal to -1 and rare value is equal to -1, then we need to display the message saying that the queue is empty. And if the rare is equal to size -1, then we need to display that the queue is full. So based on all these conditions only, we can write the logic. And that logic is shown here. So when the queue is full, then what we can do? We can perform either the deletion operation or we can perform the display operation. Suppose that now you want to delete an item from the queue. So according to the algorithm, the deletion can be done only at the front. So the element what we are deleting is collected like this. ELE is equal to CQ of front. Once after deletion, we need to increment the front value. So the front value becomes 1. So from front, it became from 0 to front value 1 immediately after the deletion of the element. Whereas in case of inserting, we are not incrementing the value immediately, but whereas in the case of deletion, we are incrementing the value immediately. And once again, if you want to delete one more element, then what will happen? Can you say what element will get deleted? So here, because the front value is 1, the element that will be collected into the queue is CQ of front, that is 20 will be collected. So here 20 will get deleted and the value gets incremented and the front value becomes 2. So here now 2 elements we deleted. So 2 vacant locations we have. So here this location and this location is free. When I say that I have deleted the elements, it is not that really the 10 and 20 values are being left. Only the cursor positions we are changing. There you will be having the values 10 and 20 itself, but we call those values as garbage values because there is no function in any programming language. Once again, I am repeating, there is no function in any programming language which can be used to delete the values that are being present in the memory location. So here, now we have 2 empty positions, but I need to insert the element into the queue. So when I want to insert the element into the queue, what will happen? How can we insert one more element? In the previous case, we have done rare plus plus, but now if I am doing rare plus plus, the rare value will become 5. But here there is no index value with 5. The index values are 0, 1, 2, 3, and 4. So there is no 5. So now if you want to insert, very simple. If the rare value is equal to the size -1, then again what we need to do is instead of making rare plus plus, we need to make the rare value to 0. That is, we need to come to the start. So here, whenever we need to insert the value, when the rare value is equal to size -1, then the rare value becomes 0. So now the rare comes to the first position. So if you insert with a new element, say 60, then it will be placed here in this particular place. Now, if I want to insert with one more value, then the condition here, rare is equal to size -1 fails. So we need to come to the previous only, that is rare plus plus. So rare will be 0 plus 1, that is 1. So rare becomes 1 and we can insert the element here with 70. Now if you can see again the queue is full. We said that the queue is full if rare is equal to size -1. That is rare is equal to size -1, 5 minus 1. But here rare 1 is equal to size -1, which is false. The condition is becoming false, but still the queue is full. So here, what we need to do is when we come or when we face such kind of situation, here we have to go for an other condition. which also represents that the queue is full. So here it is based on these two conditions, we need to go display whether the queue is full or not. That is, if front is equal to rear plus 1, then we can say that in this case also the queue is full. So the queue is full for two conditions. One is if rear value is equal to size minus 1, the queue is full. If front value is equal to rear plus 1, then also the size value will be, the queue will be full. Here front is equal to rear plus 1. So in this condition also, we can say that the queue is full. So here we can perform the insertion operations, deletion operations, and display operations by using this logic. So this is how a circular queue will get executed. Now let us see the logic for implementing these circular queues. So this is our circular queue and we have taken its size as 5 and with index values 0, 1, 2, 3 and 4. Now let us discuss the logic for the two operations. One is insertion and deletion side by side. So let us see the insertion parallelly. Let us see the deletion operations also parallelly. So we have seen that initially the front and rear values, they are pointing to -1. So here the front value will be equal to -1 and the rear value will be equal to -1. Whenever the front value is equal to -1 and rear value is equal to -1, we are going to print that the queue is empty. So here, since the front value is equal to -1, the rear value is equal to -1, the queue is empty. So to perform the deletion operation, first we have to check whether the elements are present or not in it. So if the queue is empty, then we cannot perform any deletion operation. That's why in case of deletion, we need to check whether the queue is empty or not. Now, coming to the insertion. So now, first we need to check whether the queue is full or not. So to insert an element, we need to check whether the queue is full or not. That we don't know. So that logic we will be writing later. But if the queue is full, we display this command, else we are coming to else if. So if the queue is full, we cannot perform an insertion operation. But in this case, you can see that the queue is empty. So right here, if the front value is equal to -1 and the rear value -1, which means that the queue is empty, which is nothing but we are inserting the first element. So when the front value is equal to -1 and the rear value is equal to -1, then we are inserting the first element. So whenever we insert the first element, then the logic here is if the front is equal to -1 and rear equal to -1, then the front equals to rear equals to 0. So the front value and the rear value must be equal, made to 0. So we can assign like this. So the front will be pointing to 0 and the rear will be pointing to the 0. So here the front will be pointing to the 0 and the rear will be pointing to the 0. And we can insert the element with the help of rear only. So here once after, while inserting the first element, the front and rear need to be made to 0, and using the rear, we have to insert the element. So whatever the element we want to insert, that we are collecting at the callee function. So here CQ of rear is equal to element. So this element, whatever we are collecting, that we are passing here. So here now the rear value is equal to 0. So CQ of rear is equal to element. CQ of 0 is equal to element. So 10 will be placed at this particular location, 0 with the rear. We cannot increment the rear value here. So here we will see what we can do in the later stages. So suppose we are inserting an element, say 10, then the 10 will be placed here, we have seen. Suppose if you would like to insert with one more element. So here it is else if, because See this condition, we are not inserting the second element, first element, we are inserting the second element. Then we need to come to this else if. So let us see the logic in the later stages. So the logic here will come to a else if statements. So here the logic, what we are going to do is, we need to check for else, some more logic, and then we need to go for the end function. So after insertion of the first element, if you want to insert the second element, then first step what you need to do is you need to increment the rear value. Because the rear is 0, now you want to insert, you need to insert at the first position. So the rear value need to be incremented. So it becomes rear plus plus. So the rear value need to be incremented. So it will become rear plus plus. Then we need to collect the element, whatever the element we have collected, that element need to be sent into CQ of rear. So this is the logic what we need to apply here. So here, so now the rear became 1. Then we can insert the value 20 at this particular location. So we have done it here. So whenever we are starting or whenever we are storing one more element, then the rear plus plus will need to get incremented first. So here, when we try to insert with the third element, the rear becomes 2, and we are going to place with this location with the value 30. Next, when we insert with the fourth element, say 40, then the rear will become 3 and the 40 will be placed in this location. When we insert with the next element 50, rear will become 4 and 50 will be placed here. Now you can see that the queue is full. If you notice here, now the queue is full. So when the queue is full, when the size value is equal to rear plus 1, then the queue is full. So the condition here is when the size value is equal to rear plus 1, or you can say like this, when the rear value is equal to size minus 1, the queue is full. So here you need to write when the size is equal to rear plus 1, then you need to print the message saying that the queue is full. So in the circular queue, if the size value is equal to the rear plus 1, then the queue is full. And when the queue is full, then we can perform either the display operation or we can perform either the deletion operation. So now let us see how to perform a deletion operation. So can anyone say when and how we can perform an deletion operation? So here we need to write else if. So else if some condition, again else if some condition, else some statements, then end of the function. So initially, if we want to delete the front element, first we need to collect the element from that location, and let us see how we can collect that element into the first location. So here, when I want to delete the first element, that is 10. So here, because my front is pointing to the 0th location, I want to delete this element. So how this can be done? So here the CQ of front, we need to collect the element value. So here the element value is collected by using CQ of front. Then the front value is incremented. So initially, when the after the deletion of the element, we need to increment the front value immediately. And we have to print whether the element is being deleted or not. For that, we are going to use the print command. Printf %d is deleted, and there we are presenting the element. So element already I have collected the front element here into the ELE. That is 10 is deleted, it will display. Then it will make front plus plus. So now my front value will become 1. Suppose now we are deleting one more element. So the same story repeats. Now 20 will be deleted and the front becomes 2. So 20 will get deleted and the front becomes 2. So now the front will be pointing to this location. So the front is pointing to this particular location, location number 2. Here, if you can notice here, size is equal to rear plus 1, which is true. Here also, if the size is equal to rear plus 1, which is true, but the queue is not full. So we need to check with one more condition. So what is that condition? We will see by using the R. Okay. So if you can see here, size is equal to rear plus 1. When rear is 4, size is equal to rear plus 1. When size is equal to rear plus 1, the queue is full. But if you can see here, we have 2 vacant positions. The queue is not full. After deletion, still the rear is 4. We have 2 vacant positions, but now when we try to insert an element into the queue, it will display the message saying that the queue is full. So what we have to do? We have to go for an other condition. So here in the else block, front is equal to -1 and rear is equal to -1, which the condition is false. So when the condition is false, we need to come here and do rear plus plus. So whenever I try to insert the element now, since the rear value is 4, we will get the size, the queue is, the circular queue is full. But that is not correct. So here what we need to do is, we need to write the condition like if the rear value is equal to size minus 1, if the rear value is equal to size minus 1, that is rear is equal to size minus 1. Then what we need to do, we need to make the rear value to 0. So now the rear becomes 0 and whatever the element we want to insert, that element we are going to send it into CQ of rear. So here my rear became 0. Now I am inserting that element with say 60. So I have inserted the element with 60. Suppose now if you want to insert with one more element, say if you want to insert with one more element, what will happen? Can anyone say what will happen? So here it will not go with the, so suppose I want to insert with the element 70, say 70 will be passed here. It will check whether size is equal to rear plus 1. No, condition is false. So it will come to this else block. Front value is equal to -1, rear value is equal to -1, which is also false. So it will come to here. Rear is equal to size -1. That is also false. Rear is not equal to size -1. So it will come to this else block. So rear plus plus. So what it will do? It will increment the rear value. So rear value becomes 1. Then the element will be placed here. So 70 will be placed here. So this is how we can place. Now if you can notice, again the queue is full. But here when we say that the queue is full, when the size value is equal to rear plus 1. But here rear plus 1 value is not equal to size, but still the queue is full. So even at the false condition, the size is full. So here what we need to do is, we need to check for one more condition. So that is, we need to check the second condition. So to check whether the queue is full or not, we need to go for the second condition. So here the rear value 1 and the front value is 2. So the condition is if the front is equal to rear plus 1. If the front value is equal to, see if you can see here, if the front value is equal to rear plus 1, then also the queue is full. So since front value is equal to rear plus 1, the queue is full. Once when the queue is full, we cannot perform an insertion operation. So we can either delete the element from the queue, or we will display the all the elements that are being present in the queue. Now, my question here is, which condition we need to check first? Whether we need to check this condition first or this condition first. So here we need to check this condition first. So let us rewrite the logic. That is, front is equal to rear plus 1 and or size is equal to rear minus 1. So this is how we need to write the logic to display whether the queue is full or not. So the two conditions we have to write, and this is for the insertion part. Now, since the queue is full, we can perform either the deletion operation or we can perform either the display operation. Now, let us see how to perform the deletion operation. Already we have completed one part, that is the else part we have completed. Now, to insert the element, suppose if I want to insert the element, what it will do? It will see whether the front value is equal to -1 and the rear value is equal to -1. No, this condition is not true. So it will come to this else part. So element is equal to CQ of front. Element is equal to CQ of front. That is, what is front? Front value is 2. So now 30 will store in the value element. So 30 is deleted. Then we need to go for front plus plus here. 30 is getting deleted. Then the front value is changing to this value. Front is equal to 3. Next time, suppose if I want to delete with one more element, say, what will happen? Which element will get deleted? The element 40 will get deleted and the front becomes 4. So here the 40 will get deleted and the front becomes 4. Now, again, if you try to delete with the same logic, you see what happens. 50 will get deleted and the front becomes front plus plus, that is 5. But here I have no index with 5. I have no index with 5. So I need to rewrite one more logic. Let us see how we can write. When the front value is equal to, size minus 1, we need to go for that condition. So when the front value is equal to size minus 1, we need to make the front value as 0. So when the front value is equal to size minus 1, element is collected from the front, that is, since the front is, then we need to print a percentage d is deleted. Okay, and we need to make the front value to 0. So here, if you can see here, the front is 4. When the front value is equal to size minus 1, what I am doing? I am collecting this 50 into the element. Then I am printing that 50 is deleted and I am making the front value to 0. So this is the logic what we have to apply here in this particular case. Understood? So now observe very carefully. The rear is pointing to the first location and the front is pointing to the 0th location. So the rear is pointing to the first location and the front is pointing to the 0th location. Now we have only two elements, that is 60 and 70. Now I want to delete one element. So what will happen? When I want to delete one element, so it will come here. Front value and rear value are not -1. So it will not come to this if block. It will come here. We have not written any condition. So it will see whether the front is equal to size -1. So front is not equal to size -1. So it will come here. So here we are collecting the element which is in the front. So the element in the front is 60. So it will display the message saying that 60 is deleted. Then it will increment the value plus plus plus. So 60 will get deleted first and the front value will become 1. So here both the front values and the rear values, they are both pointing to the first location, same location. So whenever in a queue, when the front value and the rear value, they point to the same location, then we can say that there is only one element in the queue, that is the last element in the queue. So here the element that is being present in the queue is only one element. Since there is only one element in the queue, now suppose if you want to delete one more element from the queue. So suppose if you want to delete the last element from the queue, that is if the front value is equal to the rear value, then when we are deleting the last element in the queue, then that is CQ of front value, we are collecting, we need to collect it into the element. And after deleting the last element from the queue, we have to make both the front and rear values to -1. So whenever we supposed to delete the last element, that is when the front value is equal to rear value, we need to collect the element into the queue, and we need to print that the 70, the element, last element is being deleted, and we need to make front value to -1 and the rear value to -1. So the front becomes -1 and the rear becomes -1. So these are all the different possible ways we can come across while inserting or deleting an element in a circular queue. So that's all for now. In the next class, let us discuss the complete programming execution on queues and circular queues. So let us write the logic for queues and circular queues, and let us execute the programs by using the C compiler and see how it is going to work. Thanks for watching my video. If you like this video, please don't forget to press the like button, subscribe my channel to get the latest notifications. And for any online classes, please contact me at 94944 70795. Thank you.